Today we're going to start talking about finding the volume of a rectangular prism. Before we start talking about it though, we do need to know kind of what a rectangular prism is, which is basically a box, like you think about something getting shipped to you in a box. All of the faces are rectangular or square, and there are 6 of them. And volume, we need to know what that is as well. Well, volume is essentially, it's a measurement of the space inside of something. So for example, if we can imagine filling up a whole space, that's what we're really talking about here. So volume means how much it takes to fill up the inside of that space. You've probably seen this before, looking at it as counting cubes, how many cubes will fit inside of something. So take a moment and look at these particular prisms and see which one you think is going to hold the most cubes. Just estimate what you think. How many cubes do you think each of those will hold? When you have made your guess, then go ahead and move on. All right, let's see if you were correct. The first one, prism A, there are 12 cubes in each layer. There were 2 layers, so it would hold a total of 24 cubes. The second one, there were 4 cubes in each layer, so not as many cubes in each layer. However, there were more layers, 4 layers. So there were 4 cubes in each of the 4 layers for a total of 16 cubes. And for prism C, there were 8 cubes in each layer because there were 4 in each row and there were 2 rows. And since there were then 3 layers, there were a total of 24 cubes. So that means actually prism A and prism C both have the exact same volume because they both hold the same number of cubes. So I've used this word cubes a lot, so think about this for a minute. How is the answer of 64 cubic units different than an area answer? We've done area before. Area we've talked about is filling the inside of a space, and it is, but it specifically is filling the area of a 2-dimensional space. When we talk about volume, we're thinking about filling up a 3-dimensional space. When you fill a square or a rectangle or a triangle or a parallelogram or whatever figure, when you fill it up to find its area, you're filling it up with little squares. Basically, you want to know how many little squares fit, so you use square units for area. But with volume, you're wanting to find how many cubes will fit in a space. So with volume, you have to think 3D. Your answer has to have a 3 after it, or your unit has to have a 3 after it, rather, because that stands for cubed or cubic units. You're seeing how many cubes fit into your shape. You're finding 3 dimensions of the shape in order to find its volume. So let's take a moment and find the volume of each of these prisms. So this first one, if we look at it, it has 3 cubes across the bottom and it has 3 rows. So that's a total of 9 cubes on each layer times 3 layers is going to be 27 cubic units. For our next one, we have 1, 2, 3, 4, 5, 6. We can fit 6 cubes across and we can fit 1 cube back. So we can fit 6 cubes on each layer, and there are 2 layers. 6 times 2 is 12. That has 12 cubic units. And then our last one, we can fit 1, 2, 3, 4 across, and we can fit 1, 2, 3 back. So we have 3 rows of 4. That makes 12 on each layer. So there are then 1, 2, 3 layers. So 12 on each layer times 3 layers, we can fit 36 cubes. So the volume here is 36 cubic units. So if you look at this, the way that we find volume then is we figure out essentially what the how many cubes are going to fit. So we essentially are doing the length times the width times the height, because we're figuring out how far across, that's our length, how far back, which is our width, and how tall, which is our height, and we're multiplying all of that. Now another way you could think about that is basically what you're doing is finding the area of the base, or in other words, how many cubes fit on the bottom, and then multiplying that by the height. Our base area for this one is 12 cubes that can fit on the bottom times 2 layers, which gives us 24 cubic units. So when we look at our formula or our rule for finding volume of a rectangular prism, we can do length times width times height. We can also think of volume of any prism, actually. The volume of any prism is going to be the base area, or the area of the base. That's what that capital B stands for, the area of the base, times the height. Now, if you think about it, that makes sense because in a rectangular prism, length times width, that's going to be our base area. So length times width is simply being replaced with the capital B, which stands for base area, area of the base. And it's helpful to know that formula, base area times height, because you'll use that later on as you try to find the area of other types of prisms. So now let's take a look at this example. In this example, we have a rectangular prism, and if we want to find its volume, we can simply use the formula. Volume equals length times width times height. We could also do base area times height, either one. You probably are more familiar with length times width times height, so whichever one you want is okay. For this one, we have a length of 15 meters, a width of 6 meters, and a height of 7 meters. Now, I specifically called 15 the length, 6 the width, and 7 the height. Technically, does it matter which one's which? No, not really, because technically I could turn that prism, and if I could pick it up and rotate it, I could rotate it and make any of those look like a length, a width, or a height. And technically it doesn't matter which one's which because we're just multiplying them anyway. And the commutative property of multiplication says I can multiply in any order and it doesn't change the product. So it really doesn't particularly matter which one we call the length, which one we call the width, and which one we call the height. But we're going to use 15 for our length, 6 for our width, and 7 for our height. And we're going to go ahead and multiply that. 15 times 6 is 90. And then when we do 90 times 7, we're going to get that our total volume is 630, and it's specifically going to be 630 cubic meters. Again, it really doesn't matter whether we do length times height times height times width times length times height. It doesn't really matter because those are really all the same formula. The commutative property says changing our order does not change the product, so we can change that order as often as we want, and it's not going to change our answer. Now, I want to point out that we can use the formula to find volume, but we can also use the volume and either of the other two measurements, the length, the width, or the height. As long as we have two of those measurements in the volume, we can find the other measurement. So when we look at this, we can say, well, we know that volume equals length times width times height. For this particular prism, its volume is 48, its length is 2, its width is 4, and we don't know its height. Well, if we go to work that out, take a look at what we know about doing this, because we know how to do this from what we've learned about algebra. 48 is going to equal 2 times 4, which is 8, times h. Well, we can solve that by dividing by 8 on both sides of the equation. The 8's cancel, leaving us with h equals 48 divided by 8, which is 6. Now notice it's going to be 6 inches, not 6 cubic inches, because height is not a measurement of volume. Height is a measurement of distance. And distances are just going to be inches, feet, yards, miles, whatever the unit is by itself, because they're just a distance. So our height on this particular rectangular prism then is 6 inches. And again, we can use our formula. Just notice this time we have to solve it algebraically because we have numbers on both sides and a variable on one of the sides. So hopefully most of what we've done up until now is a review, but we're now going to look at what about if we are trying to fill with cubes that are not whole number sides, like they're not 1 inch by 1 inch by 1 inch. Could we work with fractional side lengths with our cubes? And that just helps build on our knowledge of volume. So take a look at this. So how many half-inch cubes would fit in 1 cubic inch? So in other words, this is a cubic inch, which means it's 1 inch by 1 inch by 1 inch. So if it's 1 inch by 1 inch by 1 inch, how many half-inch cubes would fit in it? Most people say 2, which is wrong. Because then when we start thinking about it, we would say, well, if our cubes were each half an inch, wouldn't we have to say, well, we can really fit we can really be 2 cubes high because each cube is only going to be half an inch. So half an inch here and half an inch here. Well, so is it not just 2? Well, no, it's not just 2 because we can also split like this because we're going to be able to fit a half-inch cube here and a half-inch here. And then we have to think about, well, I can actually split this also because this 1-inch side here is really going to be a half-inch and another half an inch. So how many cubes can I actually fit in 1 cubic inch? I can fit 8 half-inch cubes in 1 cubic inch. And that should actually kind of make sense because if we think about what a half-inch cube is, a half-inch cube means that each of the sides of the cube is 1/2 of an inch. So the volume of a half-inch cube would be 1/2 times 1/2 times 1/2, which is 1/8 of a cubic inch. So if it's 1/8 of a cubic inch, then it should make sense that it takes 8 of them to make 1 whole cubic inch. Now building on that a little bit, take a look at this problem. The rectangular prism below is made up of cubes that have edges of 1/4 inch. What is the volume of the rectangular prism? Now, when we look at this, we're probably going to be tempted to want to say, well, it's a 5 by 4 by 3. 5 times 4 is 20. 20 times 3 is 60. 60 cubic inches. That's not right because each cube is not 1 whole inch on each side. It's only 1/4 of an inch. So, yes, we can fit 5 cubes across here, but that's going to be 5/4 of an inch because we have 1/4, 1/4, 1/4, 1/4, and 1/4 for a total of 5/4 of an inch. And then this distance is going to be 1/4 plus 1/4 plus 1/4 plus 1/4, which is 4/4 of an inch. And then this distance is going to be 1/4 plus 1/4 plus 1/4, which is 3/4 of an inch. So when I want to find this volume, I'm going to do 5/4 times 4/4 times 3/4. And when I do that, I'm going to get 5 times 4 is 20. 20 times 3 is 60. But it's going to be 60 over 64. 4 times 4 is 16. 16 times 4 is 64. So 60 64ths. And 60 64ths can be simplified to 15 16ths. So the volume of that particular rectangular prism will actually be 15 16ths of a cubic inch. And again, that's because each cube has a side length of 1/4 of an inch. So I have to figure out that 5 cubes together will make 5/4 of an inch, or 1 1/4 inches. So it would be okay to do 1 1/4 times 1 times 3/4. And if you do that, you're still going to get 15 16ths of a cubic inch. All right, let's take a look at this one. A distributor is packing Slinkies into a large box to ship them to a store. Each Slinky is in a box that is 1/3 of a foot by 1/3 of a foot by 1/3 of a foot. The box they will go into is 2 feet by 3 feet by 3 feet. How many Slinkies can be packed into the box? That's a little bit of a tricky question. It might help us to draw a picture of it. So I think I want to draw the big box that they're all going to go into. So the big box they're all going to go into is 2 feet by 3 feet. So I'm going to say 2 feet by 3 feet. And then it's 2 feet by 3 feet by 3 feet. So here's how I always draw a prism. Kind of get my diagonals going here. It's not perfect, but it works okay. So 2 feet by 3 feet by 3 feet. Now, how many 1/3 of a feet boxes or slinkies will fit in there? Well, if I think about it, basically what this is saying is it's saying 3 feet or 3 whole feet is how many thirds? Well, it's equal to 9/3. So how many slinkies can I fit going 3 feet across? Well, if they're each 1/3 of a foot wide, then I can fit 9 slinkies because 3 slinkies make 1 foot. So 3 feet then would be 9 slinkies. So I can fit 9 slinkies across. And then 3 feet, again, 3 feet is equal to how many thirds? It's equal to 9/3. So I can fit 9 slinkies back. So on each layer, I can fit 81 slinkies because I can fit 9 slinkies across and 9 slinkies back. And then how high can I go? Well, if it's 2 feet high and each slinky is 1/3 of a foot by 1/3 of a foot by 1/3 of a foot, then I can say, well, 2 feet, which is 2 over 1, is how many thirds? It's equal to 6/3. So I can stack it 6 slinkies high. So I'm going to have it 9 slinkies by 9 slinkies by 6 slinkies. So I can fit 9 times 9, which is 81, times 6. So 81 times 6 is going to be 486 slinkies. I can fit 486 slinkies in that box. That's a lot of slinkies. Definitely don't want to get those tangled up. This question is kind of similar to that. How many 1/2-inch cubes would fit inside of a rectangular prism with a length of 3 inches, a width of 4 inches, and a height of 2 inches? So try this one on your own, pause it, and when you're done, hit play and see if you've gotten it correct. Now, there's a couple of ways that you may have looked at this particular problem. You may have started by drawing your figure, hopefully, and then starting to look at it and say, well, how many 1/2-inch cubes will fit along each of those edges? And then once you know how many 1/2-inch cubes will fit, you can multiply how many cubes along each edge, and then you will get how many cubes wide, how many cubes long, and how many cubes high it is, and you will get how many cubes total will fit. So I could say, well, 2 inches, or 2 over 1, is equal to 4 halves. So the 2 inches is, I'm going to be able to fit 4 cubes along that side. So 4 cubes along this side. And then going this way for the 3 inches, going another direction for the 3 inches, 3 over 1 is equal to 6 halves. So I'm going to be able to fit 6 cubes along this edge. And then for the 4 inches, 4 over 1 equals 8 halves. So I can fit 8 cubes this way. So if I were to think back to the idea of all of our cube pictures we did earlier, if I had 6 cubes along the 6 cubes by 8 cubes along the bottom times 4 layers, I'm going to have 6 times 8, which is 48, and 48 times 4, which is going to give me a volume of 192 cubes. So I could fit 192 1/2-inch cubes inside of that rectangle, or inside of that rectangular prism, rather. Now, that's not the only way you might think of this problem. Another way you might also think of it is to say, well, I can find the volume of the whole thing, which is 2 inches times 3 inches times 4 inches, which gives me 24 cubic inches. So the volume of the whole thing is 24 cubic inches. Well, if I think about the size cubes that I'm wanting to put inside of there, they are each 1/2 inch by 1/2 inch by 1/2 inch. So 1/2 times 1/2 times 1/2 is 1/8 of a cubic inch. So each cube has a volume of 1/8 of a cubic inch. Well, if I need to fill a space that is 24 cubic inches with cubes that are each 1/8 of a cubic inch, then I can do 24, or 24 over 1, divided by 1/8. So that's going to give me 192/8 divided by 1/8, which is 192 over 1, or 192 cubes. I'm going to need 192 cubes to fit inside of that particular rectangular prism. So hopefully you have remembered your rule, your formula that you already knew for volume, which is volume equals length times width times height. and now have extended it to understand a little bit better about how you can use that to also think about different size cubes that might fit inside of a rectangular prism.